Okay, number 1. Looks like as I check to see if it's arithmetic, looks like I added 3, added 5, added 7, added 9. There's a pattern, but it's not the same number every time. It's not a constant. So therefore it is not arithmetic. And when I check geometric, looks like I multiplied by 4, but I didn't continue multiplying by 4. So it's not geometric. So this would be neither. They are in fact perfect squares. It's 1 squared, 2 squared, 3 squared, 4 squared, etc. But that's not arithmetic nor geometric. And this one. It looks like I'm adding 1/3 over and over again. 1/3, 2/3, this would be 3/3, 4/3, 5/3, so that's arithmetic. This one looks like it's not arithmetic. Let's test to see if it's geometric by checking the ratios. So when I check ratios, I would take 6, put it over 8. When I simplify 6 over 8, I get 3/4. And honestly, I may just grab the calculator to check the other ones, now that we get into fractions. So now I'm going to take 9/2. I'm going to divide it by the term before it, which is 6. Notice I get 0.75, which is 3/4 again. Then I'll take 27/8, divide it by the preceding term, which is 9/2. Once again, I get 3/4. Then I'll take 81/32. This is the last one to check. Divide it by 27/8, and I get 3/4 again. So it's geometric all the way through. Or it's constant all the way through, so therefore it is geometric. Find the indicated term. We're trying to find the 23rd term that should have been a comma after the -2. A sub n. Actually, I could put in my subscript of 23 because I know I'm trying to find the 23rd term. First term is 5 plus n is 23, so 23 minus 1 times d, which is -2. So that's 22 times -2 is -44. -44 plus 5 is -39. Number 5, we're looking for the 47th term. First term is 15. Oh. Sorry, my pencil broke. Okay, here we go. 15 plus n is 47, so 47 minus 1 times d, which is, looks like we're going down by 3, so that's a -3. I should probably, my 15 looks pretty sloppy. Let me try that again. Still not great, but you get the idea. 15 plus 46 times -3 for a total of -123. Next, I don't like really the instructions on this next section. I should have worded it better. What I meant to say is find the equation or the rule for the nth term. So this is where we're not plugging in n, we're leaving it in terms of n. So we're trying to find a sub n is equal to my first term, which is 7, plus n minus 1 times d. So it looks like we're adding 22 over and over again. Yes. Okay. So 22 is our d. Now I would distribute that 22. So plus 22n minus 22, and then combine like terms for my final answer, 22n minus 15. For number 7, I'd probably illustrate this sequence, since I don't know the first term. I actually don't know the first 5. And then my 6th term is -12. Then I don't know the 7th, 8th, or 9th terms, and the 10th term is 8. Now, I'm going to focus on the 2 terms I know and think about how I get from -12 over to 8. So it looks like it's 4 steps. From 6 to 10 is 4 steps. We can clearly see that. So I started at -12. I added d. Since it's arithmetic, I'm adding d over and over again, and I have to do that 4 times. So I add 4d, and I end up at 8. That will allow me, if I solve this, I'll be able to figure out what d is. So I see that then that 4d is equal to 20. So d must be 5. Now that enables me to figure out the first term, which is ultimately what I'm going to need. So we can do one of 2 things. I can work backwards and subtract 5, or realize that I need to, a sub 1, I'd have to add 5 once, 2, 3, 4, 5 times to get to negative 12. There's a lot of ways to look at this. Or you can use our sequence formula, but take one of the terms we know. I'm going to use the first, the term earliest in the sequence, the negative 12. That term is equal to the first term plus its in value. That negative 12, its in value was 6. It's the sixth term in the sequence, so I'm plugging in 6 for n. And I just found out that d is 5. So I can solve this now to see what the first term is. So it's 25. So when I subtract away the 25, I get that a sub 1 is negative 37. And so now, plug that in, negative 37 plus n minus 1 times d, which is 5. A sub n is equal to 5n minus 42. Okay, number 8. Find the three arithmetic means between 7 and 67. You're certainly welcome to illustrate this. So we have 7, then we have 3 blank terms, 3 arithmetic means, and then we have 67. Similar to the last problem. To get from the 7 to the 67, I'm going to add d, because it's arithmetic, 4 times. I can count it out, or since there's 3, 1 more than 3 is 4, so I end up adding d 4 times, and I get 67. So d is 60, or 4d rather is 60, so d has to be 15. And so now that I know what I'm adding, I can go ahead and manually do that. I start at 7, so if I add 15 to that, I get 22. Then add 15 again, I get 37. Then I get 52. And then just to check, if I added 15 to this, I get 67, which is my next term, so I know that's correct. Number 9. You'll see I made a correction on here. Hopefully in class you caught that. There's a few mistakes on this worksheet, in fact. This was one of them. It said like r equals 17 or something like that. It doesn't make sense for this problem. So here's what we change it to. A sub n is equal to negative 29. It's supposed to be a negative up there. And so we need to find the sum. So sum of an arithmetic series calls for us to know the first term, which we do know, the last term, which I do know, and n, which I don't know. So I have to figure out what n is before I can actually really dig deep into this problem or find the answer. So to find out what n is, I will have to think about the sequence. So a sub n, which in this case is negative 29, is equal to the first term plus n minus 1. I'm trying to find out what n is, times d, which is negative 2. So we're going to solve this. Subtract that 3, negative 32. Distribute the negative 2, so negative 2n plus 2. Subtract 2, negative 34. It's equal to negative 2n, so n has to be 17. So now I know the first term, I know the last term, and I know how many terms there are. So the sum of these 17 terms is equal to 17 times the average of the first and the last. 3 plus a negative 29 divided by 2. 3 and negative 29, add to negative 26, half of that is negative 13, so I have 17 times negative 13, negative 221. Number 10. Nice break there. Okay, so I need to know, once again, n in the first term and the last term. N is how many terms there are. Notice it doesn't start at the first term, it starts at the seventh term. So 7 to 19, you subtract those, you get 12, add 1, you get 13. There's 13 terms total. The first term, in this case, it's actually a sub 7. 7 is the first number I want to plug in because that's what it shows there. So that's going to function as my first term. So plug 7 in, 2 times 7 is 14, minus 15 is negative 1. Then the last term, the 19th term in this case, 2 times 19 is 38, 38 minus 15 is 23. So now plug all those into the formula. sum of these 13 terms is equal to 13 times the average of the first and the last. Negative 1 and 23 make 22. Half of that is 11. 11 times 13 is 143. Number 11, I know the first term, I know the last term, I don't know what the n value is. So similar to number 9, I've got to find that. So I'll use my sequence formula. I know my last term is negative 36. First term was 6. I don't know what the n value is of that last term. That's what I'm trying to find out. D, looks like I'm subtracting 3 over and over again. So minus 3, subtract 6, negative 42. Then distribute the negative 3, so negative 3n plus 3. Subtract the 3, negative 45 is equal to negative 3n, so n has to be 15. And so now I know my first, last, and the n, so I can use my formula. So the sum of these 15 terms is equal to 15 times the average of the first and the last. 6 and negative 36 makes negative 30. Half of that is negative 15. 15 times negative 15 is negative 225. Now I move on to find the indicated term of geometric. So we switch gears into geometric sequences and series now. So we are looking for the sixth term, so a sub 6 equals our first term, negative 64, times r, which is 1/2, to the power of n minus 1, so 6 minus 1, which of course is 5. So I'm going to take negative 64 times 1/2 to the power of 5, and I get negative 2. Number 13, I'm looking for the ninth term. First term is 1. Looks like we're multiplying by negative 2 to the power of 9 minus 1, which of course is 8. So I'm going to take negative 2 to the power of 8. Make sure that you put negative 2 in parentheses before you take it to the power of 8 so that your sign is correct. If you don't do that, you may end up with the incorrect sign. Now in this case, we get a total of a positive 256. Instructions on number 14 and 15 were incorrect. I said arithmetic. It should have read geometric. We have switched gears to geometric. All right, so now we've got, looking for the nth term. So it's similar, and I don't like the instructions here. It should have said find the rule or the equation for the nth term, so find a sub n. We don't actually plug it in, we just write the equation. So our first term, 243, times r. We need to figure out what r is. It might be easier to look at these later numbers, which are smaller, to get from negative 9 to 3 if you were unsure. We'll make a fraction, working backwards, so put 3 over negative 9. 3 over negative 9 simplifies to negative 1/3. So that's our r value. It's to the power of n minus 1. Number 15. We might want to illustrate this because it doesn't start with the first term. We'll have to find that. I don't have the first, second, or third terms. The fourth term is 48. Fifth term I don't have. Sixth term is 768. So as I move forward from one term to the next, I take 2 steps. So start at 48. This time, since it's geometric, I'm multiplying by r. So I multiply by r and then multiply by r again, which means in total I've multiplied by r squared, which brings me to 768. So to solve this, I'm now going to divide by 48. So 768 divided by 48 is 16. Square root, and we have to remember plus minus. So there's 2 possible outcomes here. R could be a positive or a negative 4. And so I have to consider both of those cases. So let's think about when r is a positive 4. I would need to find my first term. So Maybe I'll start with the 48. The term I have is 48. That's my a sub n. I don't know a sub 1. My r value, I just found that to be, or I'm using the positive 4 in this case. When I use 48, that's the fourth term, so it's exponent of 4 minus 1, which of course is 3. So I have 4 to the third, which is 64. So I have 48 equals 64 a sub 1. I divide by 64. And I get 3/4. So my first term would be 3/4. So this rule, it should be a sub n equals your first term, 3/4, times positive 4 to the power of n minus 1. There's one of my equations. Let's consider the other possibility, because r could have also been a negative 4. I have to check both of these. And we might have a different first term. It could be the opposite side. You can actually predict that based off of how many steps, but let's go through the process. So 48 is my fourth term. Trying to figure out what the first term would be in this case. But we're using an r value of negative 4 this time. So that was my fourth term, so 4 minus 1 is my exponent. So now I have negative 4 to the third power. That's negative 64. So I'll have to divide by a negative 64 instead of a positive 64. So a sub 1 is equal to negative 3/4. So now, for my equation, I get negative 3/4 times negative 4 to the n minus 1. So I needed to find both of those equations, because both of them would yield the same two terms that were given. Let's move to the back page. Another mistake that I made. Number 16, we had to change the term. That should read 16 over 9. So we have to find the two geometric means. I would illustrate this. We have a term of 6. I have two missing terms. It says two geometric means. And then I have 16 over 9. Since it's geometric, I know that from one term to the next, I'm multiplying by r. So in total, since I have two missing terms, I had to do it 3 times. So I started at 6. I multiplied by r 3 times. So that means I multiplied by r to the third power and ended up at 16 over 9. So I'm going to divide by 6. This is a fraction over here. So instead of dividing by 6 on this side, I want to think of it as multiplying by 1/6. Dividing by 6 and multiplying by 1/6 are the same thing. I could simplify the 16 and the 6, because they're both even, so I can divide them by 2. So at this point, I have that r to the third is equal to 8 over 27 when I multiply together. So now I've got to take the third root. Since it's an odd root, I do not need plus or minus. There's only going to be one answer here for r. The third root of 8 is 2. The third root of 27 is 3. So I have 2/3 for an r value. So now I go and plug it in. So I had 6. I have to take 6 times 2/3. So 6 times 2/3, I'll come back over here. Make sure you think about simplifying this fraction. That'd be 6 over 1 times 2/3. You can simplify the 3 and the 6. So I end up with 4 over 1, which is just 4. So 4 is my next term. Now I have to multiply that by 2/3. So 4 is 4 over 1. Nothing simplifies this time. Multiply straight across. You get 8 over 3. Those were the two geometric means, the two missing terms. Okay, now we switch gears and do sums. It's still geometric, but we're doing sums now, so we use the sum formula. So the sum of these 6 terms in a 6, it's our first term, 2/5, minus the first term again, times r, which is 5, to the power of 6, over 1 minus r, which is 5. I'll show you as I type this in the calculator. I want to make sure you get it entered into the calculator correctly. So it's pretty key to this problem. So I'm going to put a set of parentheses around the numerator. So I'll start with parentheses. I will just type 2/5 as 2 divided by 5 minus 2 divided by 5 times 5 to the power of 6. Now I'm done with the numerator, so I will close that set of parentheses. Divided by a new set of parentheses for my denominator. I can type on 1 minus 5. Of course, I could have also just typed -4. But there's my answer, 1,562.4. I'm okay with having it as a decimal. I'm okay too if you give your answer as a fraction. That's certainly allowed. Sometimes that depends on what calculator you're using or how you're entering it in, what it defaults to. There we go. Number 18. All right, so we need to know the number of terms, which from 1 to 7 is 7 terms. I need to know what r is. That's a number that got raised to the exponent. The k is on the 4, so 4 is your r. And I need to know the first term. To find the first term, you plug 1 in. So it says to start with 1, so plug 1 in here. So we have 4 to the first power, that's 4, times 3 is 12. So we have a first term of 12. Now plug those into our formula. So the sum of these 7 terms is equal to 12 minus 12 times 4 to the 7th over 1 minus 4. I'm guessing this is going to be a rather large number. So pull out the calculator. 12 minus 12 times 4 to the 7th divided by -3. 65,532. Okay, number 19. So we want to know how many terms there are. From 3 to 8, if you subtract 3 from 8, you get 5, but you have to add 1 on to account for that. There are 6 terms. R is the number raised to the exponent, that's 1/2. And then we need to know the first term. In this case, I'm starting with 3, so plug 3 in. So 1/2 to the 3rd power is 1/8. 1/8 times 4 is 4/8, which is 1/2. So we'll plug these numbers into the formula. So the sum of these 6 terms is 1/2, the first term, minus the first term again, times r, which is another 1/2 to the power of n, which is 6, over 1 minus r, which is 1 minus r, which is a 1/2. So lots of 1/2s here. So 1/2 minus 1/2 times 1/2 to the power of 6, done with the numerator, divide by 1 minus 1/2. So as a decimal, we saw that that was 0.984375. Now in this next section, we're still dealing with geometric, but now it's infinite. So there is no last term. We don't use the same formula we were just using. First thing we have to do, though, is determine if there even is a sum. Is this series convergent or divergent? To determine that, you need to look at the r value. What is it that we're multiplying by? From -12 to 6, looks like we multiplied by a -1/2. I'll check your other terms just to make sure that seems reasonable. Yes, it does. So, the rule is that we need to check and see if its absolute value is greater than or less than 1. Absolute value of -1/2 is a positive 1/2 that is less than 1. There is, in fact, a sum. So then I need to also know the first term, which, of course, we see is -12. Plug those into the formula. So your first term over 1 minus r. Once again, you may not need to see my calculator to do this one, but I just want to confirm, make sure that you see that I put the denominator in a set of parentheses. So something like this would be sufficient for an entry, and so I get an answer of -8. Number 21, now it's in series notation. I see my r value, that's the one that's raised to the exponent, it's 1/2, so that is less than 1, so there's going to be a sum again. So then I need to know the first term. It says to start with 1, so we're going to plug it in the formula. So plug in 1 for the n, 1 minus 1 is 0, we have an exponent of 0. 1/2 to the 0 power equals 1. So I end up with 2 times 1, which is 2. So my formula calls for me to take a sub 1 over 1 minus r. I don't really need a calculator for this. 1 minus 1/2 is 1/2. Dividing by 1/2 is the same as multiplying by its reciprocal, so 2 over 1. So we really have 2 times 2, which is 4. And then number 22, the r value, 3/2. That's larger than 1. Don't use the formula, please. The formula will give you an answer, but it will be wrong. The formula only works when the absolute value of your r value is less than 1. So in this case, we have no sum. It is divergent. It doesn't approach a sum. Okay, now we switch roles again to recursive rules. So starting with 23, they give you a recursive rule. We're supposed to find the first 5 terms. So first term was 4. I don't care if you list them out separated by commas or if you put a sub 1 equals, a sub 2 equals, a sub 3 equals. That's up to you. But if I want the second term, I have to take the first term minus 13. So 4 minus 13 is negative 9. Then if I want the next term, I have to plug in the negative 13, the negative 9 rather, that I just got. Negative 9 minus 13 is negative 22. And then we just keep repeating that. Now we plug the negative 22 in there. Negative 22 minus the 13 is negative 35. So at that point, we're at 4. We need 5 terms, one more. So negative 35 minus 13 is negative 48. Okay, number 24. I have 1/16 for my first term. So then I plug 1/16 in there. It says 4 times 1/16. That's 4/16, which simplifies to 1/4. Then I plug 1/4 in there. 4 times 1/4 is 1. Then I plug 1 in there. 4 times 1 is 4. Then I plug 4 in there. 4 times 4 is 16. Number 25, my first term was 4. This one, actually, I'm going to switch gears in terms of how I'm writing it. Instead of writing it separated by commas, I'm going to use the notation a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. So the first term was 4. We know that. Now, for the second term, you're going to take 3 times the previous term being 4, but we're going to subtract from it n. Now, what is this n? Well, it's the subscript of the one we just used, which is really 1 less than the subscript we have out front. So since we're starting with an a sub 2, we're trying to find a sub 2, 1 less than that is 1. So the n value here is technically 1, so I'm subtracting 1 from that. Whereas in the next one, 1 less than 3 is 2, I'll be subtracting 2. The next one, where I have a subscript of 4, subtract 1 from that, it's 3, so I'm subtracting 3. 1 less than 5 is 4, so I'll subtract 4. So I'm going to kind of follow that pattern. But let's go ahead and plug the 4 in. So 3 times 4 is 12, minus 1 is 11. Then we plug 11 into the next one. 3 times 11 is 33, minus 2 is 31. Then we plug 31 in. 3 times 31 is 93, minus 3 is 90. Then we plug 90 in. 3 times 90 is 270. 270 minus 4, 266. So there's my first 5 terms. 4, 11, 31, 90, and 266. All right, now down to this bottom section, we have to write the recursive rule. Recursive rule requires 2 things, a sub 1 and a sub n plus 1. Don't forget the a sub 1 part. That's the easy part. We see the first term is 15. Write it down. That's where it starts. Then what do? Looks like I'm subtracting 6 over and over again. So I'm taking the a sub n and I subtract 6 from it. And there's my recursive rule. Number 27, the first term is 2. Write it down. Looks like I'm just multiplying by 4, so that would be 4 times a sub n. So real tough ones to start off. 28's a little trickier. For 28, the first term is 1. And then, what do I do to get the next term? So you might have to study this one for a little bit. I think I did this example in one of my classes, perhaps maybe even both. But what am I doing to 1 to get 2, 2 to get 5, 5 to get 26, 26 to get 677? Well, I'd focus maybe on the 2, 5, 26, especially the 5 to 26. So if I square 5, I get 25, which is really close to 26. I squared it and added 1. Let's see if that's true all the way through. If I square 1, I get 1, and I add 1 and I get 2. Oh, that worked out. Now square 2, which gives you 4, add 1, does it give you 5? Oh yeah, if you square 26 and add 1, you do in fact get 677. So that's what we're doing. We're taking the a sub n, we're squaring it, and then we add 1 to that total. So there's your recursive rule.